Here we have a polynomial in standard form. We will see the steps involved in drawing a sketch of this polynomial. 1. Let's have a close look at the polynomial, and from this fx equals to 2x to the power of 5 minus 12x to the power of 4 plus 18x cubed, we can actually identify the end behavior. Okay, so what is the end behavior here? For that, we will check what? We will check two things. One, degree, and second, order. So what is the degree here? Degree of the function is highest degree. Highest is 5, so degree is 5. 5 makes it odd degree function. Is it okay? Odd degree polynomial. Second, leading coefficients. What is the leading coefficient? Leading coefficient is plus 2, or we can say just positive. Now, if the degree is 5 and leading coefficient, that means odd, odd means both sides will be opposite direction, correct? So basically, and leading coefficient is positive, that means the right side up. So the graph of this polynomial will look like this, correct? It will go from quadrant 3 to quadrant 2. Now, we need to find the zeros. Finding zeros is not easy. It could be very, very complicated. So, you have remainder theorem and you know how to divide polynomials. You have to have complete knowledge of that. Here, I've taken a very simple example which can easily be factored. Okay, to find zeros, we will equate this function to 0 and then find for what values of x do we get our 0. 2x to the power of 5 minus 12x to the power of 4 plus 18x cubed. As you can see, what is the highest number which can be factored out? Number 2 is common, and x to the power of 3. So let's factor 2x to the power of 3. And what do we get? We are left with x squared minus 12 divided by 2, 6. X and 18 divided by 2, 9. Plus 9. X cubed is factored out. Now this looks like a perfect square. X squared plus, minus 2 times 3x gives us 6, and this is 3 square, correct? So this could be written as 2x cubed times x minus 3 whole square. Well, we took a simple function. The idea is not here to teach you factoring or writing it in factored form or dividing and things like that. The idea is to teach you steps to solve. Now, we get an equation in factored form. Then, it is easy to find factors, to find zeros. Now, zeros could be at this equal to 0 or that equal to 0. Let's calculate this. So, x cubed equals to 0 implies that x equals to 0, and x minus 3 equals to 0 means x equals to 3. So, there are two zeros, right? One 0 is at x equals to 0, the other one at x equals to 3. Now, let's look into multiplicity of the zeros. So, we got two zeros, and now order or multiplicity of our zeros. Here x cubed, so the multiplicity is 3, and here 2x to the power of 2, correct? X minus 3 to the power of 2, so it's 2. So we know we got two zeros, and multiplicity of the first one at the origin is 3 and the other one is at 2. Now let's try to sketch it. So first let's put the zeros down. One at x equals to 0, here it is. And the second one is at x equals to 3. Let's say 1, 2, 3. Right. Let's review this. When we did this function, then we found that the end behavior was from quadrant 3 to 1. And then we got two zeros, one with multiplicity of 3 and the other one with 2. Now let's sketch it. So the function is going from here to there, correct? With these zeros. Now this 0 at 3 will be like this. It goes like a cubic function. And how about the 1 at 3? There it is going to bounce back because it's of order or multiplicity 2. That will go like this. Let's join our graph, right? So we'll do this like this, and there it goes. So that's kind of our function fx, and this is x. Correct? These points, as you see, are 0 and 3. So remember, to sketch a graph, we just need a couple of things, not many. One, look at the function. What was our function? Our function was fx equals to 2x to the power of 5 minus 12x to the power of 4 plus 18x cubed. Now here, this is our leading term. So leading term gives us both the things, the degree of the function and the leading coefficient. Degree is odd, therefore oppositends, and positive leading coefficient means right side up. Therefore, the function should go from 3 to quadrant 3 to quadrant 1. Then factor this out. In case you are already given an equation in factored form, you don't have to factor it out, right? Just then it's easy to find zeros. Equate each factor to 0 and find the value of x for which the function is 0. Then figure out the multiplicity of each 0, and that multiplicity will determine the behavior of graph at that x-intercept. Third step, most important, put the points of zeros and then draw, depending on multiplicity, how will it behave. So if it is cubic, then make that curve, fine curve, like a cubic function. If it is a parabola type of, or degree 2 or degree 4, it should bounce back. If it is linear, which we don't have in this case, it will just go straight line, correct? Once you do these things, then just join them up. In this equation, one more thing we should have checked, and that is our y-intercept. So let me write it here now. Y-intercept, I forgot. Y-intercept is this value for this function. When x equals to 0, find y. So that means f of 0 is what? In this case, f of 0 is 0 because all the terms here you can see have x in it. And this is very important, y-intercept, don't forget about it. Y-intercept, put this. Sometimes it is also a check. It will show you if the y-intercept is not matching, then it will show, well, something is wrong. Then review, okay? I think that's good enough, and it helps you to understand how to draw or how to sketch a polynomial. Okay? Thank you.